Okay, hello everyone. Welcome to the second day of the SQL review for the projects. I want us to begin by looking at the North Star PDF document. I'm going to touch base on what we call self joins. But I think this is the right moment to cover this topic. We've talked about joins in the past. We've seen inner joins, left joins, right joins, full joins, and a self join is basically a join that involves a table to itself. And through that process, it could be joining a table to itself using a left join, right join, inner join, or full join. So the self join right here just an indication that the table is joined to itself. That's it, right? And you can do that through inner left, right, or full join. And this is the reason why I'm going to expose you to this, because sometimes you're dealing with a concept which they're all tracked in the same table, right? For example, you have managers and employees, they're stored in the same table, and they want you to build a query which will identify managers and their employees, right? So let's take an example on the North Star. I'm going to use this. So use North Star. And this is the question right here. List all employees and their managers. This will be easy if you have an employees table and you have a managers table, right? This would be very easy. You can just use an inner join and you join the two tables. But if you notice in this North Star project we're working on, we have a single table for employees. And the goal is that employees and managers are also employees. So in this project, there was no need to put the employees and the managers on separate tables, right? So since managers are also employees, they are tracked on the same table. So let me take you to the North Star project. Let's see what tables we have available. So this is a North Star database tables. We have two tables right here. Now let's begin by exploring the employee table. Right, so right here you have manager information and employee information are stored in the same table. Right, let's do a couple of checks. If I ask you who is the manager of Smith, right, you're going to take the manager ID, which is this. Under normal circumstances, we should take this manager ID and look it up on the manager's table. You see that? So if this is the employees table, this is it right here. We should have a separate table for managers so that we can take this manager ID and look it up on the manager's table and find the manager for Smith. See, this is the ID right here. We can take this ID and go to the manager table and find that information, right? Fortunately, it's stored in the same table. The goal is that managers are also employees, right? So that's why they are stored in the same table. So you're going to stay on this same table to find out who is the manager of Smith. So if I go to this ID right here, I have to pick up this ID and look it up on the employee number column. A manager is also an employee. So you have to look up 7902. So you go to this side and look up 7902 right here. So fourth is the manager of Smith. Now you begin to understand the idea of a self join. We have to take this employee table and join it to itself and then do some adjustments to get the ability to track identify the manager of an employee. It's the same process we're going to do right here. For example, who is the manager of Allen? You have to take this number, this manager ID. This ID is called manager ID, but it's also an employee ID. It will be the employee ID of the manager. All right, so 7698, you have to look 7698 on this. So Blake is the manager of Allen. And of course, if you look at King right here, there's a president, has no manager assigned. See that? So the goal is that both employees and managers are stored on the same table. If employees and managers were stored on different table, then we'll have to join the employees table and the manager table, right? But since these two information is stored in the same table, we're going to use what we call a self-join. Now, let's begin the process of a self-join. In a self-join, you have to make two copies of the same table, and then you join the two copies together. So I will pretend as if this is the employee table. I'm going to call this E for employee, right? And then I'm going to join this table with itself using a different version, a different copy. So inner join, I have to copy this same and put it right here. See that? Without the aliases, this is going to confuse the system. You're joining this table to this. That's a repetition, right? So you now have to make two copies of it. This is the first copy. I'm going to call it E. I'm going to pretend as if this copy is the employee table, the employees table. And I'm going to pretend as if this copy right here is the manager's table. So I'm now joining an employee table to a manager table. But notice the same table. This is simply a join that involves a table to itself, and hence that concept of self-join. Right? And of course, the same process continues. You have to put the on clause right here and link up the tables. And usually you will link them up based on what you're basically investigating. Right? So the first thing we want to do is we go back to this process. What did we do? We took the manager ID from the employees table. This is becoming tricky, but just watch what I'm going to do right here. So E dot manager ID, this one. So you take this manager ID, for example, who is the manager of Smith? You take this manager, we pretend this is the employee table. That's why I'm doing E dot manager. And then we go look it up on the what? On the manager table. And while we're on the manager table, what are we looking for? We are looking for the employee number of that manager. So 7902 will be 7902 this. So we want to take that ID and match it up to this on this side. So it on the manager side is going to be the employee number. I want you to understand this switch right here. And this is basically that investigation. It's very easy if you follow it from this perspective. Take each employee, take their manager. This is the manager ID. We are pretending as if we're on the employee table. So this is what we just extracted. On the employee table, take the manager ID, which is this. Now go look up this number 7902 on the manager table. Imagine you had the manager table. You take this 7902, go to the manager table, and you're looking at what? The employee number for that manager. So 7902, we take that number and we go to this side and look it up. 7902, this is it. And we conclude that, not this one, we conclude that Ford is a manager of Smith. For Allen, we're going to do the same thing. We take the manager ID for Allen, which is this. This is where we are right now. This is our employee table. We take that manager ID, this, and then we go to the manager table, if we had that in existence, and we equate it to the employee number. We'll find out that number. This one will be 7698. We go to this side and look up 7698. Blake is the manager of Allen. Who is the manager of Blake? If Blake is the manager of Allen, who is the manager of Blake? You do the same. You take the manager ID for Blake. This is where we are, this one. And we look that number on the manager table on the employee number side. So 7839, look it on this side, 7839. So King, who is the president, is the manager of Blake, and Blake is the manager of Allen. You see that hierarchy, right? So by doing this, you've been able to take each employee and map them to their manager, and you come up with this list. I know this is a little bit tricky. I want to stop right here and make sure you understand. So you have to remember it's the same table. That's the basis of a self-join. Same table. Make 2 copies of it, give them different names. Right? A table join to itself, self-join. Then this right now, you track the concept you're trying to address. We are trying to investigate each manager, each employee, and the manager. And this is the list we get. Right. And now this becomes very interesting. The next things you have to do is it will be very important to watch carefully. At this point, in fact, let me just share this. Let me share this. Just open a new query window and put this in. I'll give you some time to explore that before we go to the next. Right. So this is basically now taking each employee and showing the manager next to. So if I want to split this into 2 parts, I'm going to have something like this. So this is the employees and this is the managers. And we can clearly see that manager of Smith is Ford. That's what they investigated. Manager of Allen is Blake. And the manager of Blake, we saw that was King, who is the president. Right. So I'm going to pause right here and give you some time to explore. This is the concept of a self-join, a join in which a table is basically joined to itself. It's the same table, join it to itself. This could be inner, left, right, or full. But the fact that the same table has been joined to itself is what we call a self-join. Questions? So if you're just joining, we are looking at self-joins, SQL self-joins. And then we have, if you go back to this website, we have that listed as an advanced topic. So these are the basic SQL. This is intermediate. This is advanced, and this is where self-joins feature. So self-join, so this is what joining a table to itself. That's basically a self-join. So we start by making 2 copies of the same table. Start by making 2 copies of the same table. And this is exactly what we did right here. So if you notice right here, we have the first copy and we call it employee. This will be easy if we had a separate table for employees and a separate table for managers. Right. So we can now just, join the employee table and then to the manager table. So separate tables. That's not a self-join. But we don't have managers table. Right. So again, if we had a manager table, if I ask you who is the manager of Smith, you take this manager ID and look it up on the managers table. You will find the manager of Smith. This is the ID right here. the manager ID. But we don't have a managers table. We have just an employee table, which contains both employees information and manager information all put together. This is very important. So who is a manager of Smith? We take this manager ID. A manager is also an employee. And when you become a manager, your employee ID does not change. So this 7902 you see right here on the manager column, if you look up that information on the employee side, you will know the manager who has this ID. 7902 is this person. So 4 is the manager of Smith. You can only achieve that through a self-join. So this question looks very simple. List all employees and their managers. It's very simple until you start solving it. Then you realize that, hey, there's no manager table. We just have one table which contains both employees and managers. So in this case, we need to make use of a self-join. And for a self-join, we start by making 2 copies of the same table. This is the first copy. I'm calling that E for employee. So I'm just trying to imagine that this is the employee table. I do an inner join with this second copy of the same table and I call it M, maybe M for manager. So I'm now mimicking the process where I had an employee table. I do an inner join with the manager table, right? And this is where things become very interesting. You have to be careful on how you code this. And I went back to this to show you how we got to E dot manager ID equal M dot employee number. Because in this right here, who is the manager of Smith, you have to take this ID. So we are pretending we are on the employee table, manager ID, this. And then you now go to the manager table and you look for this on the employee number column. So take this number and look for it on this column. And that's how we find this. And we conclude that 4 is the manager of Smith. Same thing for Allen. Who is the manager of Allen? You have to take this number, which is just like viewing E.this, and you look it up on the manager table on employee number 7698. 7698. Blake is the manager of Allen. See that? So that's how we get to that conclusion, right? You have to remember this is the same table. So we'll basically join it twice. I can separate them. This is the left side, which is the E side. These are the 2 copies. And this is the right side, which is the M side. It's the same information, but then we've been able to map the rows correctly based on this. All right. So if I want to list the employee name, show me the names of each employee and their managers. So this, as long as I'm picking up employee name from E, I will pretend this is the employee name, right? Why am I calling this employee name? Because this was pulled from the E version of the table. Remember, in a self-join, you make 2 copies of the same table. So I'm pulling this from this. This is the employee name. I put a comma right there. And then if I do this same process by pulling the E name from the manager, from the M side, this becomes the manager name. Right, this becomes now the manager name. Right, so by so doing, I've been able to show you each employee and name of the manager. And you always need to go back and fact check this if the logic is correct. You can do some random check. Our investigation shows that Clark is the manager of Miller. So go back to the table and verify that information. Who is the manager of Miller? So run that. Go back to the original table. This one. Run it. Check Miller. This is Miller right here. Check their manager ID is this. Now take this 7782 and look it up on the employee number column. 7782 says Clark. So our logic is correct. Clark is the manager of Miller. And if I go back and run that, shows that Clark is the manager of Miller. And if you understand this foundational knowledge right here, you should be able to solve all of these questions you see on the self-joined, this right here. Right. So I want to stop right here and make sure we understand this. Right. Before I can start from the bottom. This one is directly linked to what we just did. Display employee name, his date of joining, his manager's name, and his manager's date of joining. We have already built the foundation of that. Right. We just need now to go in there and adjust and return the required columns. Right. So this is what we have. Right. This is a query we have right here, which takes each employee and match them to their managers. If you want to go back into an asterisk and build this all over again. So these are two different tables. One table we've done a self join on it. Same copy of the table. Right. So if you look at this first one right here, display employee name is just basically what we did right here. The name we are fetching should come from the employee copy, this one. That is what we consider as the employee name. So I'm going to copy this. That's the first thing that is requested for us from this, right? And then if you look at this, his date of joining the company. The date of joining the company, you're going to see two hire dates. This is one, this is one. The first hire date on the left-hand side is the one coming from E. So this is the employee hire date. And then the second hire date, this one is the manager hire date. So you have to be careful in that reference. All right, so once you join the same table to itself, the aliases you provided will help you to differentiate the columns. So if I want to get the employee hire date, I have to put E dot hire date. This is the employee hire date. Right, just let me do this. Employee hire date as this is the employee hire date as the date of joining the company for the employee. Right. Now, if I want to switch to the manager side and do the same, give the manager name, I will switch and do m dot employee name. So in this is now the manager name. And give that same alias right here. So these are some of the intricacies you face when joining a table to itself. Right. This is now the manager name. And if we do the same for the hire date of the manager, we have to do m dot hire date. This is the hire date of the manager. Right. I'm just going to copy this and adjust it. This is the manager hire date. See that? And this solves that question. So Smith is an employee hired on this day. The manager was hired. It's the manager's fault and was hired on this day. I want to stop right here and copy this and provide. I'll give you some time to explore that before we go to the next question. The next question that is linked to this will be fetch all employees who are, no, this one. List all employees who are earning more than their managers. We're going to get to that. Display all employees who have joined before their managers. This will be the next question we're going to solve because it's linked to the output we've built. Right. All employees would have joined before their managers. Right. We already have the date each employee joined the company and the date their managers joined the company. We just need to add a condition to make sure that the date the employee joined the company was before the date the manager joined. Right, so we are very close to this question. Right, that's why I want to just link them up. Right, but I'll give you time to explore this. You have to understand we're doing some little manipulations right here, right? That needs to be understood. We are dealing with the same table, right? But we've made two copies of it and we've joined it. So that's the foundation of a self-join, right? And this is only possible when two sets of information are stored in the same table, right? This would have been completely different if we had a separate table for managers and a separate table for employees. It would have been very easy, just join the two tables. But we have one table which stores employee information and manager information as well. All right, they didn't thought it wise to separate this. Managers are also employees. No need to separate them to different tables. Right. So we start by mimicking that process. Let's call this and pretend as if this is the employee table. Let's call this and pretend as if it's a manager table, and let's join them. So that's a self join. The table joined to itself. Right. Are we okay? Please make sure if you have any questions, any doubts, let's address them before we go to the next. The next question is linked to this one. We're just going to adjust the dates, apply condition on the date, and we should be good to go. At the end, I'm going to provide this. This is going to be a lecture material. Make sure you have a copy of this. All right. So if you look at the next question, you want us to display all employees who have joined before their managers. We already have a foundation for that. This output is very critical. We can just bring it to the next and do some adjustments. We are already showing each employee, their manager, and the dates they join. The employee name, the hire date of the employee, that's when they join the company, manager information, and when the manager joined. So all we need to do here is add a condition, display employees who have joined before their managers. We just have to make sure that the hire date of the employee came before the hire date of the manager. And how do you code that in SQL? That is simply going to be a where clause right here. And we're going to be targeting the hire date of the employee before. See, employees who join before their managers, right? So for before, this is going to be less than. So employees who joined before their managers so we have to switch now to the M side for hire date, this side, right? So if the date of the employee, if the hire date of the employee is less than the hire date of the manager, that will give us the employees who joined before their managers. If you switch this to greater than, these are employees who joined the company after their manager was hired. If you want to get before this, it has to be like this, right? So let's run it again. You view that logic, you have to test it, right? This is very important. So we have 6 employees return, and the only thing we have to do is compare this date and this date. So Smith was hired on this date, that's 1980, right? Smith's manager is Ford, and Ford was hired in 1981. See that? Of course, Smith was hired before Ford. This date comes before this one. So this reinforces the narrative of a less than. You have to test further. Right? Always make it a habit to test your logic before you share with colleagues or your manager. Right? Run the output and investigate it if this was true. Did I need a less than right here, or did I need a greater than? Right? And go back again to the question. What am I doing? I'm looking at employees who have joined before their managers. So the hire date of the employee has to be before, in terms of occurrence of the event, this event has to occur first before this one. That's it. And the way to translate that into an operator will be less than, right? So Smith was hired on this date, while the manager Ford was hired on a later date. So this is correct. Let's test the next one. Allen was hired on this date. This is February 20th, 1981. Allen joined the company on this date. Allen's manager is Blake. Blake joined the company a couple of months after. See that? Yeah, this is correct. So we're looking at employees who have joined before their managers. So this person joined on this date, which is way before the manager joined on this date. See, Watt joined on this date. Of course, Blake, same manager, joined on this date. See, that's like average 3 months after. See, Jones joined the company on this date, sometimes in April 2nd of 1981. King is the manager. King joined the company on this date. See that? All right, so we are actually capturing the information that was needed in that question. So just simply go back to this query and add the where clause on the date. Let me share this. I'll give you some time to run this. And if you have any questions, let's address them. Right. So these abbreviations, these references are very important. If not, you're going to mix up things, because you have to remember that we are basically joining a table to itself. Right. So each column in this table will occur twice in the final result. And how do you view that? Just knock all of this and put an asterisk. Each column in this table will occur twice. The original table is right here. The original table has 1, 2, 3, 4, 5, 6, 7, 8. So if you join that table to itself, you're basically making 2 copies of it. And this is what we've done right here. I'm using an asterisk to show all the columns. And if I run this, we now have 8 plus another 8. That's going to be 16 columns. The first runs from employee number all the way to commission. To department number. The next copy takes same employee number all the way to department number. So this is the first copy, which is we're calling E. E has 8 columns, right? And then this is the second copy right here, which we're calling M. M has a same repetition, 8 columns. So those references are important. Let me back out of this. Now let's call those columns like this. So right here. Right. I'm going to look for another question that is linked to this. So get all employees who work. I'm going to come back to this one. List all employees who are earning more than their managers. This is an interesting one. Employees who earn more than their managers. So once you've built that foundation, you see all these questions are linked. They're all based on this join you've done right here. It's a very critical join we've done right here. And every one of the questions I'm answering is based on this foundation right here. All right, this is going to be an interesting investigation. Right. Are they employees who earn more than their managers? Right. So what are we doing in this case? We're comparing salaries. Here we compare the dates. So it's similar to what we did right here, but we're going to be comparing salary. Right. So you can see take that same foundation, which is this, right, and put it in this question right here. And the comparison this time, instead of dates, we're going to be comparing the salary of the employee. Is it greater than the salary of the manager? It's all employees who earn more than their managers. So just to take everything back to the origin, this is what we have. This is that, oh, sorry. This is that self-join. That's the foundation of all of this question. The self-join you see right here. All right. And then now Let me just call this thing. Well, yeah, we're gonna need this. This is the employee. I'm gonna modify this instead of focusing on the hire date. Let's switch it to salary. So since this salary is coming from the E side, that's the employee salary. I just stay with me on this. Let's modify this. We're gonna do the same modification. Yeah, we're gonna keep this one. That's the name of the manager. In this case, we're gonna switch M and we focus on the salary. This will be the salary of the manager. See that? And I'm gonna modify this as manager salary. Employee salary, manager salary. So this is the foundation we have right there. Right. So we have the employee, we have their salary, we have the manager, we have their salary. See, we are now simply testing, is this person's salary greater than manager salary? This one is no. If you compare Smith and Ford, yes, Ford is a manager, this is the salary is 3,000, this is 800, so this is wrong. Let's go to the next row. Remember, that's what the where clause is doing. It is investigating each row. So the condition we're going to put on the where clause is a simple test back to the result. This result right here, there are 13 rows. And it will simply do this investigation. It will investigate if the employee salary, that's E dot salary, is greater than the manager salary, which is what M dot salary. That's the investigation you're doing right here. Are there any employees whose salary is greater than that of their manager? And that's the investigation right there. And when you run it, yeah, we have two employees, Scott and Ford, are two employees who earn more than their managers. And it so happens that Scott and Ford have the same manager, Jones. See, if you look at the salary, you see this person is earning more than this. And they can even ask you to compute the delta, the salary difference. Right? Most businesses talk about delta a lot. Delta is a change, a difference. Right? So the salary difference will be the salary of the employee minus the salary of the manager. And this, we can call it the salary difference. That's the delta. So if we run this, so there's a $25 difference between Scott's salary and the manager, $25 difference. Alternatively, you can actually put what you expect to be bigger. We normally expect that the manager should earn more than their employees under him or her, so we can switch this. In this case, if you see a negative, then yeah, that is going against the norm, right? So if I run this, yes, so this is biased towards the direction where we expect the manager's salary to be greater than the employee's salary, right? Let me do the opposite. Let's go back to the employee salary minus manager salary. Right. So see, there's a $25 difference in the salary. So yes, there are actually employees who are earning more than their managers. Right. So I'm going to share this, give you some time to explore that. Any question, let's address, and then we're going to go to the next one. My goal is to cover all of these questions on this self-join. Okay, let's explore the next one. I want us to look at this. Fetch all employees who earn same salaries. Right. So you see that without a self-join, this question will be tricky to solve. Right. But now with the self-join, we can explore and solve this question easily. So let's fetch all employees who are earning same salaries. So if you don't want to base this on the employee manager scenario, you can just use any alias. Then that's what I'm going to do. For this one, I'm going to switch. Let's move away from the employee manager reference and let's join this table to itself using a different kind of reference. Let's just call this one T1. That's the first version of that table. Remember, for a self join, you have to make 2 copies of the same table. So this copy, we're going to call it T1, and that's the same table. This copy, we're going to call it T2. All right, so that we move away from that employee manager reference. But it's the same construct. I just have to change the alias here. It's T1. All right, I'm going to dismiss this one. All right, let's build this together, and this is going to change. Fetch all employees who are earning same salaries. So in this case, the salary from the first table, that's the first copy T1, should be equal to the salary on the second table T2. That reference has to change. See, now the focus is on salary. That's how you're going to get those employees who are earning same salary. So we'll make 2 copies of the same table. Right, we're going to get them side by side. And now we compare their salaries. See what I'm doing right here? The salary from T1 should be equal to the salary from T2. So it's going to match the employees based on their salary. Right. And then there's something important we have to recognize right here, that the same employee can be matched to himself or herself. Right, since the only condition we put right here is salary. Right, so your salary can be matched to your salary again. See, and this condition is going to pick it up. But it forgets to understand that these are the same employees. So you see that Allen salary was mapped to the same Allen. This is no longer an employee manager scenario, although it's the same construct, but then we are now focusing on salary. See, same thing, Martin or what salary was mapped to what. The ones we want to see are different employees. Yes, Martin and Watt have the same salary. You see that same salary, and that's commission salary. This and this. This is the kind of comparison we want to see. All of this one is just distraction. Right? We have to add a condition to dismiss this possibility. Let's avoid comparing the salary of the same employee to themselves. That's the foundation of a self-join. We're going to have those kind of distraction because we're doing a self-join. But the real comparison are what? An employee compared to some other employee based on their salary. So you should have on this side, on the T1, the employee name right here should be different from the employee name on this side. But the salary should be the same. So the salary column, this one, this is what we call T1.salary. This is it. Should be equal to T2.salary. So if you stay on this, you discover that each time the salary is flagged on this side, it matches what is flagged on this side. That is the condition we put right here. But to avoid an employee salary to be compared to the same employee salary, we need to add an extra condition. And that's why this is giving us 18 rows. All right, there's a lot of unwanted comparison. So how do we do that? We have to tell the system that, hey, avoid comparing the same employee, an employee to himself, to yourself. Right? So we're going to do T1 dot. What's the best way to identify an employee? You can go through the employee number. Should be different from the employee number on the other side. Right, this will avoid this Smith to Smith comparison, Allen to Allen comparison, Ward to Ward comparison. That's the same employee being compared to himself. So by adding this extra mandatory condition, why mandatory? Because I'm using an operator. So notice how the 18 rows will be reduced to this, and you no longer see that comparison. Right. So Ward is now compared to Martin, and they all have the same salary. This is Ward's salary right here. This is Martin's salary right here, and they're the same. So this is now the list of employees who have the same salary in the company. This is what you will do. See that? So self joins are something that is sometimes needed. It's a knowledge that you have to be aware of. Right? We are not comparing across different tables. We are staying on the same table. It's employee table, which has the things we want to compare, and that's how you're going to build that comparison. And you have to understand the role being played by this extra condition. These things are not difficult, but you need time to have a critical look at it to understand what's going on. Right. So let me push out this foundational query so you can take a look at it. And if you want to project the final comparison, let's say we want just the names. So t1.mname, we have to figure out a way to differentiate this. This is the, we can just call this employee one, right? Because the same thing is going to show on the other side, employee one. And for the salary, we have to do t1 dot salary. This is the salary of employee one. Right, this is just one side of it. You have to repeat this for the second side of it. So I can just copy this and switch it to T2. This is going to be T2, T2. This is going to be T2, T2. Right, and what do you notice now? The salaries will be the same. So employee one earning the salary has the same salary with this employee earning the salary. See? So what ends this? Martin ends this. So the salaries are the same. Martin ends this. What? This is a repetition. Yeah, we have to figure out a way to. Yeah, this is just repeating. So bottom line is just the first two are okay. Yeah, the first two are okay. This other ones is just a repeating. This is now treating Scott as, yeah, this is just a repetition. Let me see if I can add a second another condition to avoid. Yeah, we can just dismiss all of this. Anyway, I think it's fine. It's good. We show the details. Yeah, this one is fine. So this and this have the same salary, which is this tied to this. This and this have the same salary, which is this tied to this. Right. And this other side is just repetition, Scott, Ford. Okay, now that's fine. This other condition was very important to add it so that we prevent the same employee from being compared to the same employee. Right. See that previously we had 18 because Smith was compared to himself, same salary. Allen was compared to himself, same salary. Ward was compared to himself, same salary. So by adding this, we now result to this. Yes. So Ward has the same salary as Martin. Martin has the same salary as Ward. Scott has the same salary as Ford. And Ford has the same salary as Scott. Yeah. I think that is what that question is requesting. Fetch all employees who are earning same salaries. Let me go ahead and save this before I forget to do that. I will send out this query to everyone. This is SQL self-joins. This is very important concept. SQL self-joins. Okay, so let's see what we have left. I'm going to go back to this one and just conclude them. So this right here, so get all employees who work in the same department as Scott. There are two ways to solve this question. I'm going to show you the first option. We have done something similar. Option one, let's invoke our knowledge of subquery. Where we know something is hidden, we investigate it using a separate query, and then we call it into the main query as a condition. So what is the main thing to be investigated right here? What is the department of Scott? We want to get all employees who work in the same department as Scott, but we don't know Scott's department. All right. So it is good we investigate Scott's department. Once we know that information, we can call it as a subquery. So Scott's department, that information is not known, but we can investigate it. Right. And while you're investigating this, you must make sure you know how to connect it to the main query. So for Scott's department, we're just going to use we can use the employee table. DBO dot employee. Let's run this and see. All right. I'm using employee because it has the employee name. We have to point it to Scott. This is Scott. And then we'll ask what is the department number. So that's the investigation this query will fetch us. So I'm going to put where the employee name is Scott as the e name is equal to Scott. Sorry, this. So this is us investigating the employee number. The only thing we're interested in right here is just the employee number. So I'll go ahead and kick out the asterisk. Let me run this so that this focus our attention on Scott. And we don't need all of this information for Scott. We need just this one, the department number. All right, so what Scott's department number? That's what we need. So the return column, we're going to narrow it down to just what we need, and that is going to be the department number. So this is the investigation. Scott's department number is 20. This question would have been better if we had get all employees who work in department 20. See, I've rephrased the question without any hidden agenda. But this right here has a hidden agenda. You have to first of all investigate that information, right? Now you can use this. Now this is going to be the parent and the child query together. So the parent plus the child query, we're going to put them together. And that's the whole foundation of that. So these two combined will now give us the outcome. The parent query is still going to run on the same table. Let me put asterisk right here. So this is the parent query, right? And the parent query is going to be taking what? The department number returned from the child. That's the connection. What connects the parent to the child is going to be a condition which runs on what? The department number. This is always the issue when building your strategy to connect the parent query to the child. So we don't want to see all the employees. No, we only want to see those who are in the same department as Scott. And that investigation we've done, this is what we're now going to bring it in and put it right here, right? And if I format this nicely, you're going to see it nicely done. See, this is what is investigating Scott's department. Remember, we are returning department number, and the parent is ready to receive that department number return. This is always a problem students face. They build something for the subquery, right, and they pass it to something completely different to the parent query, and the parent query will not be able to recognize it. You cannot return, for example, department number, a department name, sorry, and then you're putting department number right here to receive it. It does not tie. See? You have to build that connection nicely. Know what will be returned by the subquery, that's the child query, so that you pass that information to the outer query, that's the parent query. Right? See, this is very, very important. Right, so what is the child query investigating? The child query or the subquery is investigating the department of Scott. That's the only thing it's investigating. Right. Now, the parent query will receive that information and relate to it. Give me only those employees who are in the same department as Scott. Now, if I put everything together and execute, this is it. And these are all those who are in the same department as Scott, including Scott himself. Scott is also in that list. See that? If you don't want to put Scott in the list, then you just simply continue a mandatory condition. This is already where clause. You can take it to the next line and say, hey, give it an extra condition. Can you remove Scott from the list? We are looking at those in the same department as Scott. If you want to put Scott in the list, then this is what you do. Right, but if you want to remove Scott from the list, this is the same condition right here. Now, in this case, we have to exclude. Let's say here, we know we are looking at Scott's colleagues. All right, so let's remove Scott from the list. This where clause is not needed. The where clause is already right here. So add an extra condition to take out Scott from the list. See? So these are colleagues of Scott in the same department. All right. But if you want to include Scott in the list, yeah, that condition is not. This is it. So these are the list of all employees who are in the same department as Scott. See, everything is tied to the same department Scott is in. See, right. This is really nice on the first option, subquery. All right, let me stop right here and share this query. So you don't need to bother about this. Just this is the correct final one right here. So that's a subquery, and it really works nicely to solve that question. Right. Please, you have to recognize the unknown in this question. Get all employees who work in the same department as Scott. Scott has no department of Scott is not known. We have not been told in this question, but we can investigate it. And that is the investigation right here. And just knowing that this returns department number, that's what the parent query will pick up. So our where clause should have that department number. So that it's going to pick up whatever is returned from this. Right. You have to understand that since this returns 20, we can just dismiss this and put the 20. But we've always discouraged this. This is hard coding. What if Scott's department changes? Scott is moved to a different department. You continue, you're stuck with the old Scott's department. But then if you put the query behind this number 20, that's an efficient way to do this. And that's how we got to this. And this is what we call a subquery. A query nested in another query. Right? And together they hit the target. See? So that's option one, the subquery approach. Option two is going to be that self-join. The recognition that we have one table, the employee table, we are stuck to the employee table. Right. So option two is going to be a self-join. Right. This is option two, self-join. You're stuck with this table, employee table. Right. And again, we're still going to make two copies of that table. Let me just put this right here. We are stuck with this table. Everything we're going to do it within this table. Right. Employees who are in the same department as Scott. Right. So first, let's make two copies of a table. That's always how a self-join is done. You begin by making two copies of the same table and then you join them. So first copy, let's just call maybe C1 for this copy. Take this and do an inner join with it itself. That's where the join concept comes, self-join concept comes in. Right, and we can call this copy 2. So we now have two copies of the same table, C1 for this copy, C2 for this one. Now the on clause, you have to build the on clause to tie with your investigation. We are looking at people in the same department as Scott. Right. So the department number in C1, so you can just put C1 dot, why am I targeting department number? I'm heading towards the question, right? Those in the same department as Scott. So the department number in C1 should be equal to the department number in C2, right? This is not enough. See, where does Scott information come in? You saw how we use this, right? We have to figure out a way to also use it right here. See, this is giving us other departments. From previous exploration, we know it's for Scott's department is this, see? Right, but this is not enough. So we need to add an extra condition right here and tell the system, hey, on C2, we have to go to the opposite table, C2, and impose that condition. The name of the employee from the opposite table should be Scott. Right, this is it. Right. So after tying the department numbers, we have to make sure that the name on the opposite table should be Scott. Technically, we should be able to survive that, you see. And so once we condition the name on the opposite table to be Scott, and we make it mandatory with the department number requirement, basically we are forcing Scott's department on the final outcome. If you notice, without this condition, things become really tricky. It just matches based on the department number. We have 70 rows. But once we add that Scott requirement on the opposite table, C2, if you do this on C1, you have something. I remember a student asked this question in the last batch. You're basically comparing Scott to himself. Sorry, you're prioritizing Scott and mapping with every other. Technically, it's the same outcome, but we just swap the position. Right. So when you do C2, this one goes to this other side. So if I put C2 right here, right, these ones will show up: Smith, Jones, Scott, Adams. They will show up on the left hand side. See, right here. So it's the same C1 or C2, it's just the positioning of the tables. Right, so this is that condition for Scott, and then combine this with the conditions on the columns on the departments, right? So this is what you have. You can check with what we had right here. This is what we had, but this is not a self-join. This is a subquery. So we still, if an asterisk right here gives you all the columns in that one table, but understand that in this case, since we are doing a self-join, asterisk will give you 2 times the number of columns, right? So this side is no longer useful. The most important thing we pulled from this C2 was Scott's name, right? So if you want to render the results, make them the same as this other one, you just have to put C1 dot asterisk. Give me all the columns from C1. C1 dot asterisk, that's the meaning. All columns from C1. And if I run this result is the same as the result we have on this side. See that? So this is something right here. It's easy to read this. C1 dot asterisk give me all the columns from the C1 table. So this is a subquery approach to solving this question. You see that Scott is also listed. Right. So this is Scott and all the colleagues in the same department as Scott. So this is a self-join approach. This one is easy to explain and understand. This is this subquery approach. Right. Okay, let me share this one. I'll give you a couple of minutes. I'll give you a couple of minutes to execute and try this out. You can address any challenges you have. Okay, let's check out what we have left on this segment on self-joins. Yes, we've addressed this question right here. What about this one? Display all employees who have joined before the managers. Yes, we've solved this one. List all employees who are earning more than their managers. We've also solved this. Fetch all employees who are earning same salaries. Yes, we've done this one as well. Select all employees who are earning same as Smith. So this question can also be solved using a self-join or using a subquery. All right, you see that there's an investigation to be done right here. What is the salary of Smith? All right. So we're looking at those who earn the same as Smith. So that's a salary question. All right. The unknown in the previous question we solved was the department number of Scott. We did not know that. So select all employees who are earning same as Smith. So we do the same. I will show you the subquery approach to solving that question. And I'm also going to show you the self-join approach to solving that question. So let's begin with the subquery approach. First investigation, what is the salary of Smith? Right, we cannot know those who are earning the same salary as Smith if we don't know Smith's salary. So that's the first unknown we have to investigate. Right, I'm going to put this in a subquery, but first let's build an investigation. Right, so the investigation is simple. Let's just go to the employee table and find out the salary of what? Of Smith. So this is the table right here. I'm just going to add a where clause and simply investigate the employee name. All right, let me limit this to Smith. This is Smith right here. This is a clerk, and this is the salary right here. So that's what we want to find. All right. We are not interested in all information about Smith. We are interested only in the salary. So I'll have to dismiss the asterisk and put salary right here. You have to be careful when building your subquery. It should just address the unknown, nothing more, nothing less. We want to know Smith's salary. That's the only thing we want to know. You see, I've kicked out the asterisk and focus only on salary. This is Smith's salary. See that? With this information, we can now go to building the parent query. And the goal of the parent query is to give us all the employees. This all the employees whose salary. So we need a where clause right here. Whose salary, and it has to be tied to salary, is the same as Scott's salary. And what is Scott's salary? This is Scott's salary right here. Let me format adjust this so that we can see. This is it. This is all we need for that connection to join the two process. This is it. And this should go back to asterisk. So in the parent query, we're interested in all the information of employees whose salary is the same as Scott's salary. So remember, we've criticized this approach of just kicking out the query and just putting the value. This will make it easy, but you see. But let's put the query itself and run this. If you notice, Smith, Smith is the only person making that salary. So let's find a way to remove Smith from the list. So the fact that we've had just one row returned, which is Smith himself, means that nobody earns the same salary as Smith. You can go back to this table and investigate. Run this and focus on the salaries of every employee. This is Smith right here, 800. No other employee has exactly 800 salary. So the fact that our result returns Smith, it's just that this is a subquery. This runs and generates this, and then this is just applied now to this. So Smith shows up again, but that's we want to kick Smith out of the list. We are looking at employees earning the same salary as Smith. So to exclude Smith, you just have to go to the outer query and add an extra condition. This is already a where clause. Just go right here and add an extra condition and say, hey, the name should be different from Smith. We are looking at others, not Smith. Yes, Smith has a salary of 800. We want to look at other people who have that same salary as Smith. So let's remove Smith from the list. So now you see nobody qualifies. So this will be the subquery approach to solving that question. Let me share this. I'll give you a couple of moments to explore that. And then the second part, we'll do a self-join. So before we get into self-join, I want you guys to explore this. Let me know if you have any question on this before we go to the self-join. There is self-join option. Okay, let's explore the self-join approach. I think we built the join. I'm gonna use the same foundation right here. Anyway, let's just build it over again. That's fine. Okay, so let's make a version of this. You can call this T1. Let's do an inner join and call this T2. Call this in. Same table, give it a different version, T2. All right, finally we have the two copies. Now the on clause on the self join, you have to always go back to the research question and check what you're investigating. Select all employees who are earning same as Smith. This is a salary question. So you have to start by making sure that the salary from the first copy should be equal to the salary on the second copy. So this should be T2. So salary on T1 should be equal to the salary on T2. Self joins, always go back and check what you're investigating so that you make sure you represent that. Right, so this is just comparing the salaries. Right, you need to bring in the fact that on the second copy, the focus should be on Smith, the salary of Smith. So this is very important to add this. Right, so T2, let's focus on the name equal Smith. Right, so while you are looking at the salary, right, we should also be focusing on Smith. Right, so if you see right here, just like what we did in the previous example, we have those 18 rows that it's just matching the salaries. Now let's run that. And we are back. Anyway, before I bring this one thing I need to indicate. I'm going to remove this for now. One thing I need to indicate, we want to prevent an employee's salary from being compared to that same employee. I remember what we did in the previous example. We prevented this comparison. So take the employee number and make sure that it's different. Don't compare the same employee, an employee to itself, to herself. See, let's prevent that self comparison. All right. So 18, you see, is going to reduce, right, to 4. All right. This is just matching the salaries. We haven't taken into consideration Smith's salary. See, and now an extra condition. That's when we can add this. The focus should be on Smith. All right. And that's how we end up having the same result as in this one. So before bringing in this condition, let's see what we had. This is just matching the salaries. See, each time you see the salary right here, this is T1 is equal to the salary right here, T2. All right. But then now adding this ensures that the comparison is focused on Smith. And this is what we get. All right. So an empty set, just like what we had in this one. Empty set. All right. Okay, so we've been able to exhaust all the questions on the self joins part of it. Right. Okay, so before we go to the projects 2 and 3, I wanted us to check out this. This is outer joins example. So an outer join will be left, right, or full join, right? I want you guys to solve this question, but we're just gonna, this is 1, 2, 3, 4. Let's address this 4, right? And these are not just straightforward joins. They have some small adjustments that you need to do. So I will save this and dismiss this, right? And I'll send it via email to everyone. So that's this one was focused mainly on self joins, right? I want to open a new script which will address this one, this assignments on outer joins. And when talking about outer joins, there are 3 outer joins. So outer joins, there are 3 outer joins. This is left, right, we have right, and we have a full, right? These are the 3. Inner join is not an outer join, right? So we have inner join, and then we have outer joins, which are now classified as left, right, or full, right? So all of these questions you see right here, let's begin with this one, right? This is just a revision, right? Let's address this, and I'll encourage everyone to go back and complete all those projects on the North Star. Right? It has very, very interesting questions, and feel free to send me a message on WhatsApp if you have some challenges on any of those questions, right? So you can use that to occupy yourself while waiting on the next module, right? So display all departmental information for all existing employees, and if a department has no employees, display it as no employees. So display all departmental information. We are still on North Star. So all departmental information is already telling you we are prioritizing a certain table, the department table, right? This is the department right here, right? And we also have an employee table, existing employees. If any, if has no employee, display this, right? So they are aware that some departments may have no employees, right? But show those ones that have no employees. So if you want to do a join between the department and the employees, you must make sure you recognize the fact that they want to see all the departments, whether or not they have an employee. So that's not going to be an inner join. This is not a query equation you will solve using an inner join. An inner join will only give you the departments that have employees. Intersection between department and employee, only departments with employees. This is very important. If you want to, let me visualize that so we can see. Let's go to this and draw. If this is department, this is employee. Departments with employees, this is the intersection. See that? Right. This is very important to read. This is an inner join. But that's not what they want. They want you to show all the departments, including the ones that don't have any employee. So if this is the department table, D, and this is the employee table, E, then you're shading the entire department table. Now you're looking at the 2 zones, the intersection, that's the inner one, and the outer side. See, there are 2 parts to this, and they want to see both. This is this part right here and this part right here. Those inside the intersection, that's what the inner join gives you. And then those outside, these are departments with no employees. And that's why they insisted for all the existing employees. And if a department has no employee, display it as no employee. So these departments right here will show up, they have no employee. On this side, instead of getting nulls, replace the nulls with no employee. Let's first of all build that. So this is an important clarification that this question cannot be solved using an inner join, because the inner join will only give you the departments who have employees. We're interested to see the departments with employees and also the departments without employees. So you can solve this question using a left join. In this case, department will be on the left hand side, or you solve it using a right join. In this case, department will be on the right hand side. Right. So this is very important. Let me clear this out and we can get to work on this. Right, so you can choose between a left join or a right join to solve this question. Right, so if I begin with a department table, then I'm already heading the direction of a left join. Because my department is on the left hand side, I'm going to call this as D. That's already on the left hand side. I must make sure I put a left join right here so that I get what all departments, all departmental information. So I do left join and I bring in the employee table. And I call this E. Now the mutual column, you can try that. It's going to be department number. We've joined this before. So this department number, this is department number. So that's what we're going to put on the on clause. All right, so D dot department number equal E dot department number. Right. Since we are doing a left join, we are going to see all departments. All departments will be listed. How many departments do we have? We have 1, 2, 3. All the departments will be listed. Accounting, research, sales, operations, all will be listed. Random. See? Now, something is very interesting about the operations department. If you look at it, has no employees. See that? The departments table has how many columns? It has 1, 2, 3. It starts with department number, name, and location. In that join, you can trace the 3 columns. It's on the left hand side. 1, 2, 3. So I can split this into 2. On the left hand side, I have this is the departments table on the left hand side. And the one I've not shaded as the employees. You see, everything from the employee side is null on the operations department. We know that the operations department is department number 40. It's located in Boston. No employee. See, why are we getting this particular department? Why? Because we're doing a left join. If you switch this to an inner join, the operations department will be kicked out because it has no employee intersection. See, it has been kicked out. We're back to 14. So you have to understand why this particular question must be solved. It says outer join. Outer joins are left, right, or full. Inner join is not part of an outer join. You see? So this is very, very important. It has to reinforce that business narrative. The operations department is a department that has no employee. You see, on the employee columns, all columns on the employee table, it is returning null. Right. So this is the foundation we've built for that question. Display all departmental information for all the existing employees. And if a department has no employees, display it as no employees. So we're going to be getting every column from the department table. Right, give me D dot department number. Give me the department name. Give me the location. Right. And then on the side of the employees, this is where things become interesting. On the side of the employees, I give me the employee number or just employee name. Employee name. Oh, not this one. Employee name. Oh, this is just going to be e name. Sorry, this is going to be null for the operations, right? And that's what they want us to do. Instead of showing that null, put no employees. So all columns from the employee side, put instead of getting null, put no employees. Any column you call from the employees table will get a null for this department. Right? Employee name, employee number, any column you call from the employees table, you'll get a null for this. See that? So they want us to, instead of getting a null for this, let's put no employee. Right. So by doing this, we've been able to show the names of the employees in each department. We are showing the department information, which is the first three columns, and the names of the employees in the department. Right. And it's very specific. If a department has no employees, displayed as no employees. Instead of getting null, displayed as no employees. I will refer you to this function. There's a function called isNull. So the isNull function simply replaces null with any value of your choice. This is very important. So I will put isNull right here. The isNull function replace any null in employee name with this. So that's what the isNull function does. Go to the ename column, and if you see a null, replace a null with no employees. Let me put a version of the original column so that you can see the adjustments the isNull function has done. So this is the original column. This will get a null because there's no employee on the, see, this is the original one, this one. But then see the one which is based on the isNull function. So the isNull function simply goes to this column. If it finds a null, it will replace the null with this. Some people in businesses, a manager always tells me, put a blank. Most managers don't want to see nulls in reports because people will come and ask, what's the meaning of null? Right, so see what they do. Instead of a null, we put a blank space. This is how you put a blank space in SQL. Some managers will give you a certain value. If you see null, put this value in the place of null. So that's the role of the isNull function. It investigates the column. If it finds a null in the column, it replaces the null with anything you type right here. When I say anything, it's anything. Right. So when I run that, see, the isNull function has seen a null and it has replaced the null with whatever you've typed right there. See, so in this question, what to type was given to us. Right, no employees. That's what we're supposed to type in that. So go to this column. If you find a null, please take note, isNull function is only looking for null. Give me null. If give me this name, if you find a null in this column, that's all. Right, so this is what we will now display. We don't need this anymore. All right, we have now worked on that, and this will be the employee name. All right, so under employee name, if you see no employees, it means that that column, that uh, department has no employees. If the employees are available, it's going to list it. All right. So that's the isNull function. All right. Some other person might decide to build a case statement. All right. Let me show you another example. So this is using the isNull function. This is option one. Option one. This is what isNull function, which will simply investigate a null and replace a null with the value provided in the equation. Option two, you can use a case statement. Option two, you can use a case statement. You can use an if function even. Let's look at an if function. These are all possibilities. All right, there's no excuse to not know how to do this. You can replace this by what? An if function. Remember, an if function states a condition. If states a condition. This is null. So when this is null, that's a condition. What do we get? If EM is null, give me this. Otherwise, just give me EM. I always remember the I function starts the condition first. If the condition is true, this is so we are testing EM is null. If true, put no employees in that space. If otherwise, show us the employee name. Right. Let's run this and see the behavior. See, same thing. So it came to this position, there was no employee, that's null. Instead of null, we do no employees. For the others that had names of employees, you just give the name. That's what this is saying. There's another option, option 3, which is the case statement. Most of you have fun of using the case statement, and this will be an easy one to recall. This is a case statement which is similar to the I function. You just simply test the condition. So the case statement begins by putting the keyword case, followed by the when, which carries a condition. When this is null, right, that's a condition right there. Then remember the case statement has when, which carries a condition, then, which carries the outcome. So when ename is null, remember we use the is null operator to check for null. We have this, then this. Now we can just push this to else. Else we have the name, then we end the process right here, and then we alias it as that. So case when the employee name is missing, that is null. Instead of giving us a null, type this in that spot. Else give us the name, and this is it. And it's true right here. Right. So these are all possibilities you can explore. Right. Let me submit these 3 possibilities for you guys to explore. I think, yeah, I'm going to provide the script. I will provide the script right here. So let me save this. This is the North Star project. Let me document it correctly. This is North Star. This is North Star project. And this is the assignments on outer joins. And remember, the 3 outer joins are left, right, and full. Right. I thought this is very important, that's why I'm going back to it. Right. So this is the first part we've solved right here. Right. You can just focus on the explanation for now. I will provide you with the solutions so you can go over it. All right, so we've achieved that. Let me just take this one. Get all the matching and non-matching records from both tables. Can somebody tell me what join can we use to get both matching and non-matching from both tables? That's basically one straightforward join. I don't think you can miss this. What join will give us matching and non-matching records from both tables? This is a full join. Matching and non-matching records from both tables. The matching ones will be right here. The non-matching ones from the left table will be right here. The non-matching ones from the opposite table will be right here. So basically, this is the picture of what a full join. Get all matching and non-matching records from both tables. And both tables right here pertains to what? The employee and the department tables. Right. This is very important. So when you read, you visualize it. That's why drawing the Venn diagram out is very, very important. It will guide you to understanding the correct join to use. Right. So next time you want to explain a full join, this is it. it gives you the matching records together with the non-matching records from both tables. And drawing this is really easy. Right. Let me clear this out and draw it again. First, you draw the Venn diagrams and they intersect. Let me repeat this. I'm going to use different colors. So if I'm using this for my department table, I'm going to change the color. I'm going to use this for my employees table. Right. For the matching, let's begin with matching. Let me use yellow for matching. Right. This is the matching. Right. Take note, inner join is always present in all join types. That's the region that is common. So this is addresses this part. Matching. Now non-matching will come from both tables. So let's begin. Non-matching on the department table. Let's fetch a different color. Non-matching on the department table. This is non-matching on the department table. Right. And they said non-matching on both tables. So you cannot stop right here. This is a left join if you stop right here. And this is what they did in the above example. Right. So this is non-matching. So non-matching has to be done in two ways. Non-matching on both tables for the D side. And then we also have to do non-matching on the opposite side. And also non-matching on this side. So the full shaded region, or everything on this on the diagram is shaded. That's the equivalence of it. Of what? That's equivalence of a full join. This is a full join right here. This is very important. Get all matching, intersection, and non-matching records from both tables. Non-matching on Z is this ones right here, outside the intersection. Non-matching from E right here. So you end up with a full join. This is very important. Right. So it is very powerful to always visualize the process. Right. So I just have to go back to what we did on the join right here and transform that. Instead of doing a left join, I'll switch it to a full join. Right. And remember, some people do full outer join. That's the full meaning, the full name of a left join. Full outer join. Full, sorry, left outer join. Right outer join. Full outer join. That's why outer joins are three types: left, right, and full. Left outer join, right outer join, full outer join, or you can just do full join. So most people don't like typing this long name. They just kick out this full. Left is it's an outer join. You just put left join. Right. So I'm gonna switch this to full. Right. You can do full outer join. It's the same meaning as full join. So you can do full join, or you can execute. You see, you don't get any error. Or you can do full outer join, execute. You don't still get any error. But most people don't like typing a lot, so they just dismiss this and just make it simple. Full join. See that? This is it. It's the full join between the employees table and the department table. So get all matching and non-matching records from both tables. This is what you're expected to do. It's a full join. Right. Now this one is more specific. Get only the non-matching records from department table. And they go further to explain matching records shouldn't be selected. This is a further emphasis. I like this kind of questions. You see a lot of them in interviews. You have to take time and draw them out. This is very important. Right. That's why I'm going back to this. Right. These topics always show up in interviews, joins, especially those tests of proof of concept. They want to test your knowledge and they give you a question, you challenge you to solve it. Right. So always begin by visualizing this. Again, I'm going to copy this. You have to know what join to use. Right. Draw out the scenario and then identify what to do next. So I have this. I have this for the department table. Let me fetch a different color for the employees table. Now, what are we looking at? What do we want to get? Let me get the green for the region of interest. Get only non-matching records from the department table. This is a department table where a non-matching records found. They are found in the outside. This is where the matching records are found in the intersection. And they told you specifically matching records shouldn't be selected. Get only the non-matching ones. This is where the non-matching ones will reside. So this question again has nothing to do with an inner join. Remember the assignments we are looking at right here, they are assignments on outer joins. So you cannot solve any of these questions in this segment using an inner join. And you can see the proof yourself. It is emphasized, it insists, matching records shouldn't be selected after telling you to only get the non-matching record. To ensure that you understand this, it insists matching records shouldn't be selected. You see, I've carefully excluded the matching records. There's an intersection. If we're interested only on the matching records, inner join. Right, so this is very, very important. So since our focus is on the department table, our join already has department on the left hand side. This will now be switched to a left join. Right. But a left join will give us this zone and this zone. We now have to add a condition on the where clause to remove the intersection. And that's how we're going to get to this. So we're going to initially we're going to start with a left join, we get this zone and this zone. Then we'll further add a where clause to dismiss this zone. So that we remain only with this one. Right, this is very important. So after you visualize this process, now you can get to work. You're doing a left join and you're going to throw in a where clause to dismiss the intersection, because a left join will give you matching and non-matching. Only a where clause will now be used to dismiss the matching ones. Right. So first, we all understand why this is going to be a left join. We are prioritizing the department table. Only get non-matching records. That's in terms of department and employee. Non-matching records from department table are those departments that have no employee. That's another way of stating this question. Only show departments with no employee. That's a business-oriented way of stating this question. Only show departments with no employee. We know that the operations department has no employee. We've seen that in my previous investigation, but this is a question that is guided towards that. Get only non-matching records from department table. And what's the interpretation from a business perspective? These are departments that have no employees. Right. So first, you initiate this process with a left join so that you get those that have department employees. See right here, all these departments have employees together with those that don't have any employee. Now we have to add the condition to dismiss all of this and stay only on this one. Right. And remember, you always have to target a key column in the opposite table. So where a key column in the opposite table is null, that's how you dismiss the intersection. Right. So a key column in the opposite table is null. So if you go to this table, a key column, it could be primary or foreign, either the primary employee number, because if this department has no employees, then the employee number will be null. If this if this department has no employees, then the department number from that employees table will be null. So there are two ways to frame this, right? So you focus on a key column on the opposite table. Key column, this could be a primary key or a foreign key. But right. So we can now say if a department has no employees, then the employee number M number from what? From the opposite table, that's E, is null. Right, it's null. So you have to target any table from any column from the opposite table, a key one, right? Either this or this, where a key column in the opposite table is null. And that's how you dismiss all of these ones. These ones have values are not null. The only one that is null is this one. And that's an indication that that department has no employees. See? This is how you isolate the department that has no employees. Right. Get all non-matching records from department table. Matching records shouldn't be selected. Right. So we are dismissing all the matching ones. If you're matching, then the employee number will be available. Right. Alternatively, some other person might solve this and say the department number on the employee table is null. For departments that have employees, the department number cannot be null in the employees table because they have employees. So an employee is hired and the department is instantly specified. See, this is the employee side of this table. This is the department side. This employee was hired and assigned to this department. This employee was hired and assigned to this department, right? So if an employee is missing the department number on the employee side, this is very important. You have to focus on the employee side. Then that department has no employees. This is the conclusion right here. So this is it. This is what you're looking at. Every other one has a stated department. Remember, we're on the employee table. But this one has no department, so that's why we're putting this condition. And that's how we identify those departments that have no employees. Go to the opposite table, we're looking at the employee table and make sure the department number is null. All employees that have nulls on department number, they've not been assigned to any department. Right. These questions are very interesting. I encourage everyone to check them out. See? Select all employees' name along with their manager names, and if an employee does not have a manager, display him as CEO. Yeah, this is similar to what we did for a self join, but now this question will be a self join with a left join, because if you do inner join, you only get employees with managers. Right? You want to get employees without managers as well. So this is a self join, although it says outer join, it's going to be a self join. This is something important to recognize. This is going to be a self join. Right. So and in this, we're simply going to focus on the employees table. Right. And make 2 copies. So the focus right here will be on the employees table, right? Because there's no separate manager table. Select all employees along with their managers. Manager and employee information is stored on the same table, right? So we're going to stay on this table and make 2 copies, right? And we can pretend as if the first copy we've made is what is supposed to be the employee. So let's call this as E. And the second copy we're going to make, please take note, if I do an inner join, I will only show employees who have managers. But if you read the question, they also want to see employees who do not have managers. So that's why I'm switching this to a left join. And I call that same copy, right? And give it a different name. This time around, let's pretend as if this is the manager table, M for manager. And then on the on clause, it will be, I think we've solved this question before. So E dot the manager ID. We're gonna investigate now the manager table and pull up the employee number. Right, this is what we did previously. This assigns every employee to their manager. Right. And guess what? This person right here have no manager. See, null. Everything on the manager side is returning null. Just to indicate that this employee has no manager. Right. And then to render this thing nicely, let's go return some columns. So from the employee side, give me the name. This is what we now call employee name, because we pulled it from the E copy, the employee copy. So whatever we're pulling from that, we're going to be calling it employee name. Right. And if I do the same on the opposite side, on the M side, E name on the M side now becomes the manager name. So I'm showing you each employee and I'm telling you their manager name. Manager name. Right. For King, employee called King, that's the president. They have no name. Sorry, they have no manager. And the question is very easy. If an employee does not have a manager, display him as CEO. If an employee has no manager, display him as CEO. So for those that have manager, put their manager name. And if you don't have any manager, instead of putting null, see, most people don't like to see null. And that's why SQL Server made available this function called the isNull function. Right. So let's repeat this and simply do this. So this is the part I'm not strategically targeting, this one. If an employee has no manager, display that as CEO. So we're going to be using the isNull function to address this. I've shown you 3 other possibilities above. Right, so we're going to target this column and put the isNull function to it. So instead of giving us a null, like what you're seeing right here, the next time we run this with an isNull function wrapped on that column, we're going to get this. Right, give me CEO when you see a null on that column. That's what the isNull function is doing. So go to that column, which is what? The employee name on the manager table. If you see a null, which is this null right here, give us CEO. Right. And that's it. See, we no longer get null. Let me show you the original copy. This is the undistorted one. It's always good to see the original and then you see what that function is doing to the original. So I've preserved the original. Nothing was done on this. This is just a natural state. And then this is what we've done on the isNull. That same. You see, instead of null, we get a CEO. That's what the question wanted. Right. Okay, so that's it. I'll stop. I'm going to dismiss this. And so I really wanted us to address this. Very important. And you will do the rest. Right. So I've done the self joins and I've done the outer joins. You have the other ones to do. Right. This an equi join is simply a join with the equality operator used. Equi is coming from that equality. So it's just the regular joins we've been doing. So you guys will work on this one. Right. If you have any challenge on any of these questions, just let me know. Right. I will send out the script so you can go over them. Right. Okay. So now it's back to you guys. I'm going to go back to the solutions. We talked about the first project last time. I think that was the finance one. No, the customer insights one. Take a look. Is that what we did last time? Yes, last time we talked about the customer insights one. Yes. So on the second project, are there any questions that you want us to specifically address? So the second project is a finance analysis one, right? And the last project is the healthcare one. So I'm just going to open both. I know you've had these solutions for a while. Are there any questions on this list that you want me to target, address? You can go over them. So we have the finance, healthcare analysis, and the finance one, the last two projects. If not, we're just going to end here for today. Oh, and that's the end of the course for SQL. And also in the email, I've provided you with lecture, some additional materials to prepare you for interviews. Right, this right here, this email, everyone should have received this. So this files, you're going to see some interesting questions. 45 most asked SQL questions. This is just 100 most asked SQL questions. This is just an answers. There are also answers provided. Right. So it's just to help you prepare. Sometimes you don't really feel like studying. You can just go over these PDF documents, question and answers, and prepare yourself for SQL interviews. Right. Okay. So Idris and Lana, any question before we go? The only strange one you may want to check out is the last question on healthcare analysis. The healthcare analysis one has a certain question that talked about the cumulative count. And that's basically, you're going to need a window function for that. There was a question on cumulative count. Write a SQL query to calculate the cumulative count of visits over time ordered by the visit number. You may experience this. You're connected to the right database, but your script is showing you these funny errors. But if I run the script, it pulls up the correct result, you see. So it's just to refresh the script, right? You know how to refresh an object. Click on the object and refresh. How do you refresh a script? We go to the edit, IntelliSense, refresh local cache. This is going to refresh the script, right? And once the script is refreshed, those off funny lines will go away, right? So the cumulative count is a window function concept. Right, there's cumulative count, there's cumulative sum when you use a sum function. So you're basically summing up visits as they occur. Right. So if I add an order by right here, order by the date in the visits came in. This is very important, you see. So if you notice, this is the very first visit came in on 1st of January 2022. So that's one patient came in, you see. So starting on this date, we have to start adding the counts as they're coming in. The next date, 2 patients came in. These are 2. So if you stay right here, the cumulative count is 3 because 2 came on this date, 1 came on this. So as you're going down, you're adding. That's the meaning of cumulative. All right. How much salary did you make in the month of January of this current year? How much salary did you make in February? This is currently we're in March. See? So your cumulative salary will be summing all your salary you made from January, February, and then currently is March. When we get to April, we're going to add. And as you're going, the months are going, you're adding. That's the cumulative behavior. So this is a cumulative count of the visits. It must be guided by some time frame. That's why you put order by visit date. So we're going to start on the first visit. On this date, 1 patient visited. On this is the same date, so 2 patients visited. See, so while we are on this, the cumulative will be the 1 from this plus the 2 from this as 3. If you want to see that behavior, you have to use a window function. So you count the visit ID over, you have to order by visit date. So the system will sort the data just like I showed you on this result right here, and now start doing the cumulative count, how they occurred. Right, so this right here is what we call a cumulative count. That's that's a question that might give you some headache on that project. Right, cumulative count of the patient visits. Right, and every other question was, I think, well documented. You can just read the solutions. If you have any issue, just send me a message with the name, the number of the project, and I'll take a look at it. Yeah, so this question right here. Right, so everything is well documented in the solution. Just take great time and go over, especially the ones you had challenges in solving. Right. Okay, I think we should end right here for today. Yeah, so this is the end of the SQL model. I think Velin is going to make an announcement on when Power BI is going to start. You definitely have a break, maybe 1 or 2 weeks break before starting Power BI. Right. Please feel free, reach out to me if you have any questions. Right. And I think I did talk about the idea of creating your LinkedIn profile. I received a LinkedIn request from Alex. So Alex has that set up already. I want to encourage everyone to do the same. Right. So if I just go right here and search Alex. So Alex has his LinkedIn profile set up already. Right. This is very, very important. Right. So I encourage everyone to do the same. And so far he has 62 connections. That's really something great. So please do the same. So Idris, Lane, and Lanita, you should do the same. You can set up maybe data analyst intern at Orange Cameroon or MTN Cameroon. Just set up any company you know around, and just have that presence on LinkedIn and start sending out connection requests, and you build your profile. This is very, very important, right? Any question on this? Okay, we're gonna stop right here. Bye, everyone. See you. I think we might meet during final revisions or interview preps. But always feel free to reach out to me if you have any question. Just send me a message on my WhatsApp. Right. Okay. Bye, everyone.